All right, guys, I'm going to work from 34 backwards. 34 is by far the hardest problem. Okay, here we go. This is for my honors and some of my super, super high kids. Okay, so a group of 20 movie tickets that cost a total of $170. A group bought 20 movie tickets that cost a total of $170. The group bought large drinks. The group also bought large drinks and large popcorns. No one cares about the popcorns. That's not even part of the problem. They're just throwing that to make it confusing. How many adult tickets were bought? Okay, here's what we know. We know there were a certain amount of adult tickets. We'll call it A. We'll call them A. We know there were a certain amount of student tickets. We'll call those S's. All right, if you add the A's, the adult tickets plus the student tickets, we know that there were 20 tickets sold. So if you add A plus S, I don't know why I put this so far apart. Adults plus students equals $20. Okay, now that's just for people. How much did they spend? Well, let's see. It's $12 for every adult ticket. It's $12 for every adult, plus it's $7 for every student. So plus $7 for every student equals, and that's how you got the $170. Okay, so now we've got two equations and we've got a column. If I put them underneath each other, we can use elimination to solve this. Okay, they want to know how many adult tickets are bought. So here's what I'm going to do. I shouldn't have put that line in there yet. Again, I understand this is a hard problem. This would be upper echelon. All right, I'm going to multiply this one by -7. And the reason why I'm doing that is so instead of A's, I've got -7 A's. Instead of 1 S's, I've got -7 S's. Instead of 20, I've got -140. I made everything 7 times bigger and also switched the signs to negative. Why am I doing that? Now I can let them battle. 12 adults minus 7 adults is 5 adults. 7 students minus 7 students, the students are gone. 170 minus 140 is 30. I divide by 5. And apparently adults equals 6. So there were 6 adult tickets. Pretty tough, huh? The hard part is being able to, well, there's 2 hard parts. Being able to write the equations that adults plus students, there's 20 of them. And if I spend $12 for every adult and $7 for every student, I have $170. There will be this problem tomorrow, but we're just going to switch the numbers. So if you write this down and take notes, hopefully you'll be able to cheat off your notes. All right, here we go. 33. This one's easy. Which ones of these are functions? Remember, functions are just one guy can't have 2 jobs. All right, well, this one would be I start at 4 and I go up 2 over 1. So the graph would look like that for this equation, right? So we can test it by going like this. Yeah, that's a function. Everything we've been doing this year, those are functions. All right, this guy. One guy cannot have 2 jobs, but I see 3 has job 6 and 3 also has job 7. No. This guy, now when I do my straight line test, I hit boom and boom. That is illegal. That means this point right there has 2 jobs. This guy right here does this job and he does this job. That's not illegal. That's illegal. No, sorry, no. And finally down here, let's see. Does one guy have 2 jobs? 6 has a job. -6 has a job. 0 has a job. -2 has a job and 2 has a job. Yeah, nobody has 2 jobs. Okay, that's good. So, one guy can't have 2 jobs. That's what a function is. Okay, let's see. This guy, is this a straight line? Well, when I'm drawing a straight line, if I start here and go up 1 over 2 and up 1 over 2 and up 1 over 2 and up 1 over 2, then things are going to stay in a straight line. Straight lines, your slope has to stay the same. So let's see. What's the slope from here to here? Up 6, down 3. So 6 divided by -3 is -2. Okay, let's see. This one goes up 12 down 6, up 12, down 6, then yeah, that's still -2. So all I did was skip a point. But yeah, the slope from there to there is -2. So we're still good. The slope is staying in a straight line. From here, the slope goes up 6. Over here, it goes down 3. 6 divided by 3 is -2. Yeah, all these from point to point, the slope was still -2. So every time it went in a slope, starting from one to the other, the slope was -2. That's a straight line. And what's the rate of change? What's the slope? -2. Doesn't matter which point you used. Okay, so is this a straight line? Yes, it is. Yes, it is. Okay. Let's see. Ooh, long problem. 31. All right, Louisa solves the equation for x. She concludes that 5, this was supposed to be 5, is the only reason for x, is the only solution for x. Is she right? Let's see. She does all the work right, and she gets down here to 4 equals 9, and she thinks she has to minus 4 from both sides. So she minuses 4 and minuses 4, and she gets 5, and she says x equals 5. But this was not the right step. Once all the x's are gone, because see there's 6 x's over here and 6 x's over there, so they're going to cancel each other out. Once they're gone, this means no solution. You've done all the work right. She just didn't know what it meant. So she did all the work right, and 4 equals 9 means that there are no solutions, right? So in a lot of these problems, the work is going to be right, just they don't know, like they're going to get to the end and tell you either 4 equals 4, which is infinite solutions, or 5 equals 6, which is no solutions. So 4 equals 9 is no solutions when the x's get rid of each other. Okay, let's see. One crate can store 8 to the 7th toys. A warehouse receives 8 to the 9th toys. Okay, so what does this mean? Let's say I have a box that can hold 2 toys. A box holds 2 toys, but I have 10 toys. How many boxes do I need? Well, I take my 10 toys and I say, okay, I can fit 2 into every box, so I divide that and I'm gonna need 5 boxes. So you take your toys and you divide by how many your boxes can hold, and that's how many boxes you need. So let's see, how many toys do I have? I have 8th to the 9th power toys. And I'm going to divide by how much a box holds, which is 8 to the 7th. And this is division, so 1 less than division is subtraction. This is 8 to the 2nd power, which is 8 times 8, which is 64 boxes. I'm going to need 64 boxes. That is such a big number. There's no way that that's how many toys a thing holds. But you would need 64 of those boxes to make it happen. All right, for this one, 29. Kyle he says, this guy is 4 times bigger. And the reason why he said so, he's like, look, the radius is 4 times bigger than the other radius, and the height is 4 times bigger than the other height. That makes this 4 times bigger. But he's wrong. Here's why. We actually have to, if we want to compare them, we actually have to find the volume. We actually have to find the answers of how big are these. So basically, it's 2 problems in one. Let's see the big one. First, we start with a pirate square. Right, we start with the pirate square, pi r squared, and we have to give it some height to make it a cylinder. Same thing with the little guy, pi r squared, give it some height. So for this one, it's 3.14. The radius is 4 times the radius twice, and then the height is 12. In this one, 3.14, the radius is 1. We multiply that by, or multiply by it twice, and then the height is 3. So this one, if I'm going to do it on my calculator, 3.14 times 4 times 4 times 12 equals 602.88. This one is 3.14 times 1 times 1 times 3. This one is just 9.42. So Kyle tried to say that this was only 3 times bigger, that if I multiply this by 3, I get 602. That's not right. So how many times bigger was it? Well, let's divide 602 divided by 9.42. Let's see how many times this one goes into this one. How many times bigger than that is it? 602.88 divided by 9.42 is 64 times bigger. So if these were the measurements, this one will hold 64 times as much as this one does. So you can't just make assumptions. You have to do the math. This one, Carolyn uses the equation to find the missing side in length of a triangle. So if she's using, this is the a squared plus b squared equals c squared. So it says, which assumption does Carolyn make first? Well, first off, before anything else, the only time that you can use a squared plus b squared, and we don't know what she called it, x equals 10 squared, is if it's a right triangle. That's the very first assumption. So the very first, if I give you this problem, you're assuming that it's a right triangle, because if it's not a right triangle, we can't even begin to use this formula. So they're not even saying like do the math or anything like that. They're saying before you even do this problem, what do you have to assume first? So she says Carolyn uses the equation to find the missing side of a triangle. Well, we're assuming that if she uses that equation, it's a right triangle. So that's kind of a tricky question. It only works on that. It does not work like a triangle like this. You can't use that equation. It has to have a perfectly right triangle. All right, this one's simple. If I want to make a straight line like we talked about earlier, the slope has to stay the same. So you see how this slope is up 1/3? That means if a point wants to be on that line, it's got to be on the same slope pattern, up 1/3, up 1/3. So the missing spot has to be right there. So to stay perfectly in a straight line, you have to have the same slopes. So where is this? This is at 3, 4. So let's see. Enter the x coordinate. On the x line, we're at 3. On the y coordinate, we're at 4. That's where that spot is to make it a straight line. All right. Which one of these satisfies the equation? We've done a lot of these. We take my x, I cut it in half, and then I add 7. All right, I can do that in my head. I start with -8. I cut it in half. I've got -4. I add 7. I get to +3. Yep. If I start with -8, it turns into +3. Yes. All right, let's try this one. If I start with 11, I cut it in half. I'm at 5.5. That means divide by 2. If I add 7, I get to 12.5. Yep, 11 takes me to 12.5. Yep, it does. Let's start with 0. Cut it in half, it turns into, well, still 0. And then if I add 7, it turns into 7. So yes, 0 turns into 7 using that equation. Yes, it does. Let's see, 3. 3, cut it in half, becomes 1.5. I add 7, that becomes 8.5. No, this is not on the equation. 3, 8.5 is, but not 3, 10. So no. All right, let's see. This should be easy. Starts at 5, so +5. And let's see, the slope is going down. If I use my right arm, this is downwards, so I know it's negative something. Let's see. Down 1/1, down 1/1, that's -1. But I don't write -1x, I just write negative x's. So for this one, begin on blue number. Begin on blue. Then the right arm test. Because if you put that this is going up and you say up 1/2, you're going to get it wrong. That is not right. And then finally the slope. Okay, let's see. This guy. Okay, hard question, no doubt about it. This is for honors and above. Honors and super high regulars. Okay. Brad and Sally make 63 cakes. So I don't know what Brad is. We'll call him B. However many Brad makes plus however many Sally makes is 63. Okay. Now, Sally's is 23 less than Brad. So Sally is equal to Brad if you took away 23 from him. So that's what these, now that I have two equations, I can actually solve this. This equation tells me anywhere I see an S, I can plug in B minus 23. Anywhere I see Sally, I know Sally's 23 less than Brad, so I can plug in Brad minus 23. So over here, I can take out Sally and plug in Brad minus 23. Brad plus Brad minus 23 equals 63. 2 Brads, because B plus B, minus 23 equals 63. I'm going to add 23 over here, add 23 over here. 2 Brads equal 86. 2 Brads equal 86. Divide by 2. Brad equals 43. And if we take 23 away from Brad, so if we minus 23, 43 minus 23, that's 20. So Sally made 20. Does that work? Yeah, 43 plus 20 is 63, and 43 is 23 more than 20. Yep, Brad made 43. All right, let's see. This one, all of these questions are the same. One company starts low, one company starts high. The low company, their product is more expensive, so they grow very fast. The other company's products are kind of cheap, so they don't grow very fast. So the prices don't go up very fast. And eventually, at some point, the cheap guy becomes the expensive guy. So is only one company a straight line? No, they're both straight lines. Do the graphs never run into each other? Yes, they do. All of these problems, they do. Is buying from one company always more expensive? No, if I only buy a little bit, I should go with the black line. If I buy a lot of pencils, I should go with the green line. So no. So the company with the least expensive option can only be determined if I know how many pencils I'm buying. Yeah, if I'm not buying very many pencils, I'm going with the black company. If I'm buying a lot of pencils, I'm going with the green company. So that's all these problems. I didn't have to read it. That's just, if you see two companies or two anythings, somebody's starting low, but they're passing them up. Okay, let's see. Anywhere I see, I'm not even reading the instructions, anywhere I see a y, I can plug in 6x minus 2. So over here, I see a y up there. So 3x minus 1/2, I'm going to take the y out, and I'm going to plug in 6x minus 2 equals 1. I've got 3 x's. Now I've got negative 1/2 times 6x is cut 6 x's in half, that's 3x, but now the negative makes it negative. I have negative 2, I'm going to cut it in half, that's negative 1, but the negative makes it positive 1 equals 1. 3x's minus 3x's is 0, and I have 1 equals 1, which is infinitely many solutions. If that doesn't make sense to you, here's another way you can do it. Ready? This is my x, this is my y. Let's see if they work. This one's easy to plug it in. If I plug it into this one, if I take my x and multiply it by 6 and subtract 2, do I get my y? Let's see. If I start with 5 and multiply by 6, I'm at 30. And then when I subtract 2, I should be at 28. So this point does not work. So no, it's not that guy. If I start with 3 and I multiply by 6, I get 18. Minus 2 is 16. No, this point doesn't work either. Maybe I don't know how to do this question, but at least I'm down to 2 choices. If they give me 2 answers, if they give me some answers and I don't know how to do the math, I'm just going to check them. All right, let's see. This one. Okay, I'm at negative 1. This is like the last problem. Negative 1/2. Okay, so I'm cutting in half, and the negative makes me switch the signs. So I'm cutting 6 x's in half. That gives me 3 x's. But the negative makes it negative. I'm cutting 4 in half, that's 2, but the negative makes it negative 2. So plus 3x equals negative 2. If I've got negative 3x's and positive 3x's on this side, what I really have is no x's on this side. So I have negative 2 equals negative 2, infinite solutions. All right, and I think we got back to all of these. Yeah, I think we did these in class. So we should be good. Okay, bye.